In this problem, we're going to take a look at part B in this video. In part B, we're given some number of moles of HOCl and a volume. And of course, we'll start by dividing the moles by the volume in order to get the molarity. With my red numbers, that works out to be 0.789 molar HOCl. Now, let's take a look at that in the ICE table, because there's a couple of interesting ways we can go with this. First of all, we only have product in this setup. We do not have any reactant. So we've got zeros on the left side of the chemical equation, which is rare. We don't often see that. According to Le Chatelier, we would shift toward the zeros, and we define all of the changes in terms of x. Remember to carry the coefficient into the expression. And if we were to write an expression for K, we would take the concentration of the product squared over concentrations of reactants and we'll just plug in our equilibrium expressions. Remember to keep that exponent 2 for HOCl. And x times x works out to be x squared. We have a perfect square. Back up at the top of the problem, they give us a numerical value for K. So let's set that equal to our expression. And then if you want to get rid of the squares, we'll simply take square root. So if we root both sides, it's just a little bit of algebra from here. The root of 0.09 is 0.3. We'll get our x terms all on the same side. And x works out to be, in this case, 0.343. So going back to our ICE table, if we know that the concentration of H2O is simply x, then that is also 0.343 molar. And the concentration of Cl2O is also x, that's also 0.343. For the HOCl, we would need to take 0.789 minus 2 times 0.343. And in that case, so that would be 0.789 minus 0.686, which works out to be 0.103. So there we have 3 concentrations for H2O, for Cl2O, and then lastly for HOCl. Now, if you hadn't recognized the perfect square in the expression, then you would have been thrown off. And here's why. When you go to type, let's say you went with the solver feature on your calculator, when you go to type in an expression with x in the denominator, your calculator is going to give you an error message because it is searching for solutions to the equation for which x is very close to 0. And if you're dividing by something that either is equal to 0 or is very close to 0, then of course that's undefined. You can't divide by 0. So your calculator is going to say you can't do that. Now, there is a workaround. What you could do, let's say you're stumped, you didn't recognize the perfect square, but you did realize that, hey, if I wrote the reverse equation, what if I said, all right, I'm going to make HOCl the reactant, and H2O and Cl2O the products. And I'm going to keep the same numbers, like 0.789, 0, and 0. And you'd work out the ice table just like before. And you go ahead and write the expression for K, where this time we're putting Cl2O and water on top, and the HOCl in the denominator. Then you would have x squared all over 0.789 minus 2x, quantity squared. And that would be equal to some value for k. Now, if you remember back towards the beginning of chapter 13, if you're given a certain value for a k, for a certain equation, and you flip the equation around, you can find the new value of k by taking the reciprocal. So 1 over 0.09 is equal to x squared over quantity 0.789 minus 2x, close parentheses, squared. And your calculator would not give you an error message because it's 0.789 minus a small number, minus 2 times a small number that's close to 0. That means you don't have zeros in the denominator. So you could use the solver feature with the reverse equation, but your calculator is going to give you an error message if you try to type in using the solver feature with the forward equation. But as I mentioned earlier, and as we worked out, this is a perfect square. We have terms that are squared in the numerator and the denominator, and we've already worked out the solutions, 0.343, 0.343, and 0.103.